Okay, let's start. Okay. So today we have more example about the general likelihood ratio test. Okay. And the first question is when we have n data, they are uniform 0 theta. We want to run a general likelihood ratio test with the theta equal to 1 versus theta is not equal to 1. Okay. So question 1. So let's find our likelihood test statistic. Okay, so this is 1, S1, to Sn. And the numerator is the suprema, theta below to theta 0. And the denominator is suprema theta to all space. And here is the product of I to n. And Fi condition theta. Okay. And we know that in the theta 0 only have 1. They only have 1 point is equal to 1. Is 1. So the numerator is equal to theta equal to 1. And the denominator is equal to the MLE estimate. Okay. Okay. So now we can plug in the density. In the numerator is 1 with power n times the indicator function Si smaller than 1 and greater than 0. Okay. And this is for I. And in the denominator is 1 Sn for n. Because we know that under okay. So this is so maybe I write this. This is a theta hat MLE. And we know that this is Sn, the largest value. Okay, so this like this. An indicator function of Si smaller than Sn, greater than 0. This is for Oi. Okay. And you can see this is trivial. It's always true. So we can get rid of this term. Yeah. And okay. So and we change this to Sn to power n, and the indicator function below Si. And this term can become the Sn smaller than 1. Okay, so we will have the function like this. The left cell is not important, so if the greater than 0 is always true, so we don't have to care about this. So this is our likelihood ratio test statistic. Okay, and the thing we have to be careful is this function is not an increasing function. Increasing function of Sn. Okay. So we can draw a graph like this. Okay. So this is Sn. Here is 1. Okay, so you may look at this. This is here. So it's a function like this. So this is not an increasing function. And if we want to run a likelihood test, we will reject when the lambda x is really small. So you can see our rejection region is when Sn is greater than 1, and for Sn is smaller than less than C. Okay, so this is our rejection region. Okay. So we have defined the rejection region, which is we reject when Sn is smaller than constant C, or Sn is greater than 1. Okay. Okay, so now we have to find the C alpha. Okay, find C alpha. So we can find the probability of the rejection. Probability when we reject under the rule. So it's Sn smaller than C, and Sn greater than 1 under the rule. Okay. And we know under the rule is theta equal to 1. And when theta equal to 1, this is not happen. So this is equal to, okay, like this. And it's easy to calculate. Right? This is equal to C to the power n. Okay. So the alpha, C alpha is alpha to the power 1 over n. Okay. So we have we reject when Sn is smaller than alpha 1 over n, or Sn is greater than 1. Okay. Okay, so that is our likelihood test. Okay, let's go to question 2. Okay, the question 2 is we have two data, x and y. They are binomial distribution, and we want to run a test when rule is p1 equal to p2, and the alternative is p1 is not equal to p2. And we want to run a likelihood test, and we have to use the negative 2 log likelihood ratio. So we know from the theory, this one is follow the chi-square distribution for the dimension of the theta d, theta minus the dimension of the theta d no. Okay, so we have to figure out what is this 2. Okay, for here we have p1 equal to p2, so we only have one phi parameter, so this is 1. And underneath we have two phi parameter, p1 and p2, so this is 2. So this is a chi-square 1. So now we have to figure out what is this, and we use the chi-square to run a likelihood test. Okay. So x and y. Okay. So in the denominator we have a suprema p1 equal to p2, and in the denominator is p1 and p2. And we can use the density of the binomial distribution. It can be n1 to x, p1 to the power x, 1 minus p1 to the power n minus x, 2y, p2y, 1 minus p2, n2 minus y. And the denominator is the same. So we can do some in the numerator P1 equals to P2, so we can do the thing like this. Then we use P, this P, okay. And in the denominator, we can separate the P1 and P2 because these two terms are independent, so it can be like this. So P1 P2. Okay. And the numerator is the suprema of P, and we can combine the thing like this. Ps plus y, a1 minus p, ny plus n2 minus x minus y. Okay. So now you can see we have a 3 MLE. So this term is which is run the MLE for the data binomial with n1 plus n2 with power p. And this term is the MLE with the binomial n1 p1. And this term is the MLE binomial n2 p2. Okay. So from this you can notice the in the numerator this p MLE is the well we use p hat equal to n1 plus n2 x plus 1. And here we have p1 hat equal to n1x. Here we have the p2x hat equal to n2y. Okay. So we can do some algebra. It can become the p hat x divided by p1 1 minus p hat x and 1 minus x. How about you? 1 minus and 1 minus x, and the p hat divided by p2 hat y, 1 minus p hat divided 1 minus p2 hat divided by n2 minus y. Okay, so I just plug in this 3 to the p and p1 and p2, then we can get the formula like this. So if we have the data x and y, then we will be able to calculate the lambda. Then we can do calculate negative log lambda x and y. And we know that because now follow chi-square 1, so we will reject if this 2 is greater than x alpha 1. Okay. So this is the this is 1 minus alpha quantile for the chi-square 1. Okay, so that's all. That is the likelihood ratio test if we use the negative log likelihood. Okay.